The reusable camera framework provides a proven and well-tested feature set for connected single-sensor or multi-sensor camera solutions that will significantly reduce your development effort and time to market for your vision-based products. Now, this framework allows you to configure key parameters of different camera sensors and provides real-time control over capture, render, and post-process activities on video streams or images. In this video, we will take you through the RCF installation process, the software installation process on the Aikri 6490 development kit running Linux.
I mentioned there's a nice user guide document which basically mentions a lot of details about what this kit contains, every connector, and how to get the kit and the host device, host computer, Linux or Windows, ready, install software on this kit. So let me mention where you can get this user guide from. So the user guide in question is this Aikri QCS6490 Smart Camera Dev Kit user guide, and it can be obtained from the eInfochips Support Center. That's supportcenter.einfochips.com. I mean, you will have to contact us to obtain access to this website. We'll be greeted with the dashboard. The user guide in question, this user guide, is placed in the user guide section under Documents, User Guide. And these are all the devices that eInfochips has user guides or documents available for. Our device in question is a QCS6490, so we'll quick click on that. And for the Smart Camera Dev Kit, especially when we are trying to install the reusable camera framework, we are interested in the Ubuntu Aikri QCS6490 Ubuntu 1.0 EI, and then the version number, the software user guide. This is the user guide which I have here. And this user guide contains a lot of good detail about the hardware components, software components, and then getting the host machine ready for flashing. And you can even build the source code. And this guide contains information on how you can get the development machine ready as well, if you wish. And there are a whole bunch of sections. We will mostly follow section 4 and section 5, which will help us install the software. Yeah. So this is the user guide that you would need to download from the eInfochips Support Center, talking about where to obtain the software to install on this board, right? So that software is located in the Files section. So in the Files section, or navigate to the File sections on the left navigation pane, Files, accept the license agreement, and then we'll do the same thing. We'll go to the QCS6490 directory, and over here, it's the naming convention is similar. For the reusable camera framework, we would need to choose the Ubuntu 1.0 EI package for the QCS6490. As of the recording of this video, the latest available package is 1.0.0. Obviously, when you view this video and visit this support center at a later date, a newer version may be available over here. So just pick whichever is the latest version available and go ahead and download that. Keep in mind, this is a relatively large download of 5 GB, so depending upon your internet connection, it might take a while. So maybe prepare in advance and download this in advance. I have downloaded these packages. So obviously the third package that you see over here is the reusable camera framework software package. So this is the operating system package. So I have downloaded these packages already on my Linux machine. This machine is running Ubuntu 20.04. So I've downloaded the user guide. I've downloaded the operating system image that we just saw on the support center. And I've also downloaded the RCF reusable camera framework release package for this particular board, which is our Aikri QCS6490. The RCF package will be available in the same section. So you'll be able to download the operating system image and the RCF package together from the same spot. Let's continue. So first things first, we would have to unzip QCS. Before we start installing stuff, there is a setup process, as we saw, for this host machine. So the setup process, configuration required for the host machine. So let's refer to this document, and let me just mention. So it talks about the system requirements. It talks about the driver for a Windows machine. It is necessary to install a few drivers. The links to whatever necessary drivers are available in this document. Once you have followed all of these host computer setup instructions, you may proceed to the next section, which would be installation of the operating system image. So the package that we just downloaded, and then we are going to extract that package as well. The contents of that package are basically mentioned over here. For the scope of this video, we'll be mostly interested in the pre-builts directory within that package. As soon as the extraction is done, my device is already connected to the computer. We will proceed with the installation. Extraction is complete. So I will cd into this directory. I will cd into the pre-builts directory again. We will choose the images perf build of our operating system. The major difference between perf and debug is the debug build enables the serial terminal output port on the board, which is right next to the USB-C connector that we had seen before. It's useful for debugging if you need to, but images perf basically disables that. It has some performance optimizations as well. So we will, for the purpose of this video, we will install the perf image. Now, as mentioned in the instructions, I guess I went slightly ahead, but we were supposed to make sure that our device shows up in ADB, which it does. We would just go ahead and issue the commands. We will just follow the user guide that we have available. So ADB root, this restarts the ADB-D on the device as root. And we would then the next step is ADB reboot bootloader to reboot the bootloader reboot the device in fast boot mode. But after a second or two in fast boot devices, our device will be listed. Excellent. So we have our device in fast boot mode now. Once the device is in fast boot mode, we can just go ahead and run our fastboot flash script, a convenient fastboot flash script that has been provided for this same process. So all we have to do is fastboot flash .sh and enter and let the script do its work. It takes about a minute or two. The operating system image has been installed on the device. Congratulations. We have made it through so far. So the next step is to install the reusable camera framework that is available. If you're unfamiliar with what the reusable camera framework is, in the document section of our support center in the user guides, there will be a user guide for the reusable camera framework as well. That's a very handy user guide, which provides a detailed introduction of RCF and what it is and what it does and what it does not do and all the features it provides. So there will be an RCF user guide available over here or so. You can refer to that. So let's continue on the RCF installation. So now we know that the device is back in ADB mode. In order to install RCF, we would have to basically run ADB on the device in root with root privileges so that we can install the software. This is only necessary for the first time. Once RCF is installed once, then the RCF web user interface provides a very convenient way of installing firmware updates from there directly without ever needing to open the ADB shell. So for now, I would restart the ADB-D on the device as root and then ADB shell. So now this is the command prompt we have for the device. Now everything we do on here is directly running on the device. So at this point, we don't need the user guide. We are done with the OS installations. I'll minimize that. Open this in order to check if the device has fully booted and it has a valid IP address, which in my case, it's this address. So we have checked that. And the next step would be there's a data partition, which is present on the device. And in this data partition is where we would want to copy our RCF package. This is a package we want to install on the device. So what we would do is we would adb push RCF and then /data. So this command would copy this package from our host computer into the data partition or the data directory of the device. This package is relatively small. It's less than 100 MB versus this package, which was about 5 GB in size. Okay, so the RCF package has been copied to the device. Now we will open the ADB shell again. And then we will navigate to the data directory. Over here, we see our newly copied zip file. We would unzip this zip file. We would cd into the unzipped directory. We would see it has basically the complete package and all the files necessary. All that needs to be done now is run the install rcf.sh script, which we will go ahead and do that. When running the script for the very first time, you may see errors like this because it's trying to back up any existing configuration that may be there from the previous installation. Since this is the first time, there is no previous installation, so you see these messages. Now, the next step, as I had mentioned while talking about the hardware itself, is it would ask you which sensors are connected. We need to tell it that. We know that we have 2 sensors connected to this board right now, so we will select the dual sensor option. And then we know that for sensor 0, we have the Sony IMX476 sensor. So I will select 3 here. For sensor 1, we have the Sony IMX586 sensor connected. So I would select option 4 for sensor 1 here. And after we select that, it says that it configures the configuration database automatically. And this installation script will automatically reboot the device as well. After the device reboots, we wish to find the IP address of the device. Since we are connected to the ADB shell itself, we'll use this method. But the other method of using Avahi or Bonjour discovery service is also available, which is mentioned in the user guide, RCF user guide, and we can use that too. But for the purposes of this video, we'll just go ahead and run the ADB shell. So first, we make sure that our device has rebooted and it's available. We will open the ADB shell. This is the device shell now, and we will run the ifconfig command to find out the IP address of the Ethernet 0 interface of our device. In my case, it is this IP address, which I shall copy, and then I will exit out of the shell for now. So now that we're done with the Linux terminal, I will minimize that, and I will go back to our favorite browser, and we will open the web interface of our RCF device for the first time using the IP address. Now, upon trying to open the web interface of the RCF device for the first time, the RCF framework by default includes a self-signed SSL certificate, which Chrome will complain that I cannot really trust that device. Since we know that this is a trustworthy device, we will go ahead and add an exception and proceed to our device's web page, which Chrome will try to scare you that it's unsafe, but we know it's safe. So let's continue to our device. So this is upon trying to set up the device for the first time, we need to set up the first user of the device. And this first user of the device would be the first administrator of the device. So let me just go ahead and create a sample account. Now that the account has been created, I will go ahead and log in as that account. And I am greeted with the home page of my RCF device.